Good morning, grade 9s. Today we are still working with proving congruency, but we're going to a next level now where I'm not asking you to prove the triangle's congruent. We're going straight into proving angles and sides equal using congruency. So I'm going to work through 3 examples with you today and they become a little bit more tricky. So let's read the question. That is what you're asked to prove. So it's not saying prove the triangle whatever is congruent to triangle this. It's asking you to prove that angle B1 indicated there is equal to angle C1. That's what they ask you to prove. Okay, how would you prove it? Now remember, congruency helps you prove corresponding angles and sides equal. So my advice to you is, obviously if you have parallel lines, etc., you will look to see if you can get alternate angles and corresponding angles. If you don't, like in this case, congruency is the way to go. Now, what is given in this information is that by is equals to cx. So step 1, read the question, mark the given information on the diagram. So by is equal to cx. So it's that line is equals to that line. And you can see the triangles are shaded, one is striped and one is dotted. I think let's use a color to identify the 2 triangles. So let's use this one. And there is an overlap of the 2 triangles as you can see here. Now why am I choosing this triangle, by the way? I'm choosing this triangle because based on the given information, you look for B1. B1 falls in that triangle only. You can only use that triangle if you want to prove it equal to C1. And C1 falls in this triangle here. So you've got to use C1 there. So you've got to look at what you're asked to prove. And then you've got to first identify which triangles will help you prove that. Okay, there's no point in proving ABC congruent to anything because B1 doesn't fall in ABC. The whole of B falls in ABC. B1 only falls in triangle, the pink triangle. Please look out for that. And as you can see, there's a little section that's overlapped. So obviously we're going to use that in our proof. What other information is given? That x is equal to y, which is equals to 90. So there's another. Is x in that triangle? Yes. Is y in the other triangle? Yes. So I can use that information. In the same way, I can use by and cx because it forms the whole length of that triangle. Okay, so let's list our reasons. So So our required to prove is B1 is equal to C1. They're not asking us to prove congruency, you have to know. So this is an application question of congruency. Okay, proof. Okay, so I'm going to prove congruency. And because I'm going to prove congruency, I'm going to write it down like I would. Now which triangles am I going to use? I'm going to use BYC. Okay, so okay, let's go in alphabetical order. BCY and triangle. Now BCY is equal to, we'll say C, because C1 and B1 are going to be equal, CBX, because Y is equal to X. So the X has to go to the end. The Y is equal to the X because it's given. So in those 2 triangles, let's find out what's happening. So remember, you draw your lines. Okay, first thing, what's given? We started with triangle BCY, so we've got to mention Y first. Angle Y is equal to angle X is equal to 90. And that's given. Remember, because it's a right angle, it doesn't mean you will use right angle hypotenuse side. You could use anything else. Excuse me. Then there was a set of sides that's given, by. So if you look here, by is equal to cx. So we're going to start with by is equals to cx. It is given. Now, by and cx are not the hypotenuse sides. So we've got a side, we've got a right angle. Do we have an hypotenuse? So which is the hypotenuse to triangle BCY? There's triangle BCY. There's your right angle, so BC is your hypotenuse side there. And then let's look at the other triangle, which is BXC. There's your right angle BC there. So what do we know? BC is the common side, and BC is also the hypotenuse side. So, and they are equal. So BC is common. And in this case, you will have to use right angle, hypotenuse, side. So therefore, triangle BCY is congruent to triangle CBX RHS. Now, you don't stop there because the question didn't ask you to prove triangles congruent. The question asked you to prove that those angles are equal. Now, because you have proved that those triangles are congruent, and B1 falls in that triangle and C1 falls in that triangle, therefore, B1 will equal to C1. And what is your reason? So that's the question answered. Your reason is triangle BCY is congruent to triangle CBX. Okay, example 2. Here's example 2. Prove that AE is equals to CD if AB is equal to AC and angle A is equal to angle C. So let's mark it down. So we need to prove that line AE is equal to line CD. Okay, so there's the line. Let's highlight it so we know what we are working with. AE and CD. So those are the two lines we need to prove equal. We don't know that they are equal at this point, but we do know that AB is equal to AC. Okay, now how do we choose the triangle? So you look at what you have to prove. You've got to prove AE. So AE is there. So I can't look at AD as an entire length, and AE forms part of this triangle here. So I've got to use that triangle. If I can prove that triangle congruent, there. And then you look at the other side that you need to prove, and you need to prove CD. So CD is part of this triangle. So that's the triangle you need to prove congruent. Okay, so select the correct triangles. It's important. So RTP, what are you required to prove? You are required to prove that AE is equal to CD. Okay. Proof. How do you prove it? You prove it by proving congruency. Now that we are aware of which triangles we're going to use, let's name them. So if I say ABE in triangle, ABE and triangle, so ABE. Now we know that AB is equal to AC, so I'm going to say AC first because we know that AB is equal to AC, and obviously it has to be D. Remember, it is essential to name the triangles correctly. So what's happening in these two triangles? Let's look for three things to help us prove. The good thing is here we have a set of parallel lines, and remember, with parallel lines we can look for those equal angles. Okay, so where are the parallel lines? Where do we start, grade 9s? So we're looking for ABE and we're looking at ACD. So there we go. Angle A is equal to angle C. It's given. It falls in the triangle that we're looking at. It's given. So that's reason 1. Then it was given that AB is equal to AC. It's part of the triangle. So AB is equal to AC. That is also given. So what's our third reason? So we've got an angle, we've got a side, we've got parallel lines. What can we show equal with parallel lines? Now if you think, there's your parallel line and there's your F, that angle is equal to that angle, correct? Why are they equal? They are equal because it's corresponding. Now the next thing we have to do is to see if it falls in the right triangles. Yes, E falls in triangle ABE, and D falls in triangle ACD, and E is equal to C. And if you look at the way we named it, E is equal to D, sorry. So angle E is equal to angle D, and you can actually get you can check your answer by looking at the way it's named. Why are these angles equal? Corresponding angles, because remember, with corresponding angles you've got to name the parallel lines that form them, because they are not equal if they're not formed between parallel lines. So we've got AAS, so therefore triangle ABE is congruent to triangle ACD, AAS. Therefore, AE is equal to CD. Why? Because triangle, you have to say this, they are equal because the triangles are congruent. One more example. Now, I thought it was quite important to bring up a question like this. This is taken from your textbook because the questions get a bit complicated and your terminology in geometry is quite important and it comes up a lot here. Right, so we're going to go through this example. Prove that triangle ADB is congruent to triangle CDB. So question 1, you are proving. So let's divide our page all the way down so we can use the same page for all 3 questions. So what are you asked to prove here? You are asked to prove that triangle ADB is congruent to triangle CDB. Proof. Right, let's look at what we have. So remember, you start by saying in triangle ADB and triangle CDB, what do you have that will help you prove these two triangles are congruent? What 3 things do you have? So we're looking at ADB and we're looking at CDB. So straight away you can see the 2 dots are telling you those 2 angles are equal, those 2 sides are equal, and there's your common side. So let's start. Because I mentioned this triangle first, I'm going to name AD. AD is equal to CD, given. Okay, D1 is equal to D2, given. And there's the common side. DB is common. Or you can say DB is equal to DB common. Therefore, triangle ADB is congruent to triangle CDB. And that is because side included angle side. You can see the angle is between the 2 sides. So it is applicable here, SAS. So that answers question 1. Question 2. What does question 2 want? Why is AB equal to BC? So now that is the remaining, yes, it's the remaining side of the 2 triangles. So remember, congruency proves identical triangles, which means that all the corresponding angles and sides will be equal to each other. So why is AB equal to CD? Sorry, CB, AB is equal to CB because you've just proved the triangle ADB is congruent to triangle CDB. So therefore, that side will have to equal to that side. Okay, number 3. Show that ADC is perpendicular to BD. There's a new word. Show that ADC is perpendicular to BD. Okay, first step. What does perpendicular mean? Perpendicular. So show that ADC is perpendicular. So in other words, we need to show that this here is a right angle, D1 and D2. So you have to show that D1 is equal to 90 and obviously D2 because D1 is equal to D2. Now how would you show that D1 and D2 are 90 degrees each? Let's think about it. So remember, perpendicular, you always follow the question. ADC is perpendicular. So that we are trying to show that this intersection here must be 90 degrees. That's what we are trying to show. And you can only do that by showing that D1 is 90 and D2 is 90. Now you've got to use congruency, class. Now, ADC is a straight line. Agreed? What does that mean? There's a straight angle formed at angle D. So what does that mean? That D1 plus D2 is equal to 180 degrees, because angles on a straight line add up to 180 degrees, and this is angles on a straight line there. That's a straight angle. Now we know that D1, we know that it was given here. It's given there in the diagram. D1 is equal to D2. Given. And if D1 plus D2 is equals to 180, therefore D1 has to be 90. D2 has to be 90. Therefore, ADC is perpendicular to BD. Okay, guys, I think that's enough examples for one lesson. Please go through the work schedule, go over these examples again, and attempt the exercises. Bye-bye.